Alrighty, so when we're looking at this first integral, we need to figure out which case we're going to use. For these problems, it actually tells you the cases. I'm not sure if the homework does. I'm going to make the homework right after this. Sorry about that. But if the homework doesn't tell you the cases, just go back to your little list and look at the green descriptions, okay? In this case, we have something on the bottom that we can factor, right? And when we factor it, they're just lines. We have two lines. So essentially, we're going to be using case one, where the denominators is a product or a multiplication of distinct linear functions. So that's perfect. That's going to be case one. So essentially, we can break up the bottom to look like this, okay? So I've rewritten this black part as this red part, okay? And now we know that this is equal to some random A on the top plus our B on the top, okay? And on the bottom, we just write our two different linear equations. So here we have x minus 3, and under this one we have x minus 2, okay? So you just follow this chart right here, okay? So from here, we need to solve for our A and our B. Okay, and just to kind of connect all this together, this portion right here is coming from this 1, 2, 3 thing. So remember, essentially we're starting at 3, which was here, and then we're working backwards to make it look like this, right? So this right hand side is this number 1. So once we figure out what A and B are, we can take the derivative way easier, okay? So for us to be able to do that, remember we have to have common denominators, right? So essentially we're multiplying the top and bottom here by x minus 3, which, I'm sorry, there's already a 3. So x minus 2 on top and bottom, which is why there's an x minus 2 here. And over here, we're multiplying the top and bottom by x minus 3. And that's where this came from. And over here, we don't multiply by anything because it already has both of them, okay? Now, from here, we can choose numbers for x to be, as long as we plug it in for the entire equation and then solve for our letters. So it's good to plug in numbers that will make the inside of these go to 0, right? So that way variables go away and then we can find our other letters. So if we let x be equal to 3, this b will go away. This 3 will become a 1, and over here we'll get -1. So a is equal to -1, okay? And then we can use this same equation right here. You'll see I'll put black stars in all the problems where we're plugging them into, okay? And now to get this to go away, we need x to be 2. So if we plug in 2 here, we'll get a 0. Over here we'll get -1, which is where this -b came from, -2, and we'll get b is equal to 2. Okay, so now we take this equation right here, and now instead of A, we're going to write -1, and instead of B, we're now going to write 2, okay? And now we can solve this regularly. And because it's in that form, which I told you we're going to be using for like all of these problems, where the derivative of the bottom is on the top, we can use the natural log absolute value one, okay? So we're just going to pull this -1 out to the front, and now we have the natural log of the absolute value of the bottom, and the derivative of the bottom is just 1, so we're good, okay? Over here, the derivative of the bottom was 1 again, so we're just going to pull this 2 out to the front and then do our natural log of the absolute value of the bottom, and then evaluate it from our points. Remember, when you're evaluating, it's always the top minus the bottom, and whenever you subtract, make sure you use parentheses and then distribute those parentheses, okay? So that's why this is a plus and then this becomes a minus. If they have the same natural log, you can combine them. So this right here and this right here will become this -3 natural log 2, okay? And that's the final answer.